And you mentioned the idea of problems. I think another characteristic of system dynamics is its problem orientation. Its objective of improving the system, or if you like, its objective of designing systems. Let's go down that road for a little bit.
Well, because we focus on problems that people care about, a lot of the work in the field has been on, in the context of certain applications. And that is sometimes seen as being opposed to system dynamics as a science. I would like to hear what you think about that. It is true that most of our work has been application specific. Yes?
Yes, and I think it's a fair characterization that in academia, that's not always viewed as a good thing, that you're too applied and you're not creating a general theory because each piece is, it's just a specific application to a special place. But I think actually, referring to one of the things we read today, which is your discussion about nonlinearity in higher order social systems, the fact that we work on just specific applications rather than general theories is just a consequence of the systems that we're dealing with. There are not general theorems typically about nonlinear systems, and if you're working in nonlinear real systems, which most of the ones of relevance are, you're going to be limited to applications. So I think that criticism, I mean, it's wrong for a number of reasons, but that's probably the principal drawback or principal weakness to that argument.
It is very interesting, though, that there's sort of two approaches to science we run into. One is the axiomatic approach, which is start with a very simple set of rules and deduce everything else staying within those rules. The goal being that hopefully you can be more cumulative in that manner. If each piece somehow logically follows from a very small set that everyone agrees on. Obviously, there's the drawback that if the axioms are wrong to begin with, you might create a very, very wonderful looking but completely off base science out of that for years and decades to come. But the other approach is often associated with the biological model of going out and finding specific things and categorizing them and understanding them very well as individual pieces. And I think the system dynamics method, as we practiced it, fits better into that second model, which is we don't have a set of axioms. We don't decide that all firms use exactly this piece of structure to decide their inventory levels, and all firms use this, and it's just by recombining those that we'll figure out all of the firm problems we have. There's some element to that, but it's not that rigid. We do go out, look for specific instances, try and learn about the structures there, and try and answer those problems. And I think part of the debate is this lack of axiomatic element, and I think one can reject the axiomatic approach in many contexts to begin with.
Let me go back to Nelson and ask what you believe other people believe when they say we do not have a general theory. What would they mean by a general theory, and to what extent do they ever have what they define as general theories?
Well, I think it's, Scott alluded to it, at least in the social sciences. I think the closest, or the proponents of the general theorizing approach are typically people in economics. And there, the vast majority of models are built based on a very small number of assumptions. And they're almost always the same ones, relating to rationality and optimization. And I think their notion of general theory is somehow you could take this very small set of rules and explain everything. But not surprisingly, it's a field where the applications to real situations are relatively few and far between. And we could debate why that might be the case. But system dynamics, with its application focus, typically uses a different. I want to sort of take issue with what Scott said before, which is I think system dynamics models do exactly what you start out with, which is take a small set of assumptions and try and deduce a wide range of behavior. I mean, if you look at Jay's world dynamics model, that has to be the sort of world record for parsimony, right? You have 5 levels and you're explaining the entire planet. But on the other hand, in system dynamics, it would be absolutely foolish to take those same 5 levels and go over and tackle a supply chain problem or an urban problem or something like that. We don't hold ourselves to that small set of assumptions. And I think that's where that criticism of no general theory comes in, that because we don't use the 5 same equations over and over and over again, somehow we're just sort of working on randomly selected examples. which I don't agree with, but I believe that's the genesis of that criticism.
Well, let's ask the question, what is the possibility in system dynamics of having some general models? Maybe not a general model, but having some general models.
Well, this is something that you've suggested and was in our readings about the potential in respect to management education of having maybe 20 or so models, a couple dozen models that covered a great deal of the types of situations that at least managers within a corporate sense run into. And I think that's a very powerful thing. I think there's also been the backlash, though, to the idea of archetypes and causal loop diagram versions of the same thing, where people might be too quick to assume that their structure, in fact, fits with one of the small set of general models, and that there's an issue with respect to teaching and with respect to future work of making sure that people don't immediately assume that the story that's already been told is their story. You often find people say, oh, my story is just this, but of course it's these little changes that then twist the story all around and make the conclusions of the original model inappropriate. And so I think while we want to have some general structures, I think we need to make sure people don't assume too quickly that those structures apply in any given situation.
Let's go back to your mention of archetypes and the possibility of their being misunderstood. It seems that the archetypes that are in sort of the popular domain, largely, I guess, or significantly coming out of Peter Senge's Fifth Discipline book, those archetypes given there are the result of many people's work doing specific computer simulation models. And what is in the book are just a summary of some of those results. The kind of generic or transferable models that I have in mind are ones that are true simulation models. They are thoroughly explored. Every one of them will have multiple modes of behavior, and if you understand them, you must understand all of those different modes, and you must understand how to look at real life and make a determination as to whether one of those models off the shelf is applicable or not. And of the hypothetical 20 models, which I talk about, and probably only 4 or 5 or 6 could be identified at this stage, my feeling is that every one of them is a book-length document. Every one of them is subject to almost an academic term of study to thoroughly understand it, thoroughly understand all of its modes, understand the policies in it that affect the behavior, and understand how you would walk into real life and make a determination as to whether the model applies or not. This goes 100-fold beyond the idea of archetypes and a flow diagram. And it's that kind of a vision, I think, that constitutes potentially a new kind of management education, and is one of those things that system dynamics can gradually be moving toward.
And I think that discussion highlights what the principal danger or weakness is in the archetype approach, which is that, or what I worry about is that people say, I have a particular behavior in my organization. I know that this structure or this archetype produces that type of behavior, therefore that's my problem. And I think that's just the opposite of what the core of system dynamics is really about. Where the generic structures come up is exactly in structures, which is, oh, I've been to one corporation, it is set up this way. This looks reasonably similar like the structure of this other setting that is possible. And as you pointed out, even very simple models can have multiple modes of behavior. And in fact, given a behavior mode, an infinite number of models can generate it. So going from behavior to structure is very problematic. And I fear that with that simplified version, people typically are going the wrong direction rather than they're recognizing similar behaviors rather than similar structures.